Even though NASA's James Webb Space Telescope, JWST, has just recently started its mission, the cosmos is already opening up previously unsolved mysteries. Scientists and astronomers from all around the world are fascinated by one of these wonders, a strange visitor from the depths of space. When it was originally discovered, this object, called Oumuamua, confused scientists and resisted early attempts to determine its origin and function. However, we now have a better understanding of this mysterious visitor because of the James Webb Telescope's sophisticated capabilities. The first actual image of Oumuamua has been shown by the telescope, igniting a fresh round of interest and enthusiasm. Our solar system's first known interstellar object is Oumuamua, which translates as scout or messenger in Hawaiian. However, what is it? Could this weird visitor have a more unusual, even unearthly, origin? Or is it just the result of normal cosmic phenomena? Within the scientific community, this subject has sparked both debate and interest. A comet or asteroid are more common hypotheses, although some experts have even hypothesized that Oumuamua might be a probe from a highly developed civilization. No matter where it came from, Oumuamua has emerged as one of the most fascinating space objects in recent memory, and its discovery represents a critical turning point in our knowledge of the universe. The narrative of Oumuamua starts on October 19, 2017, an apparently typical night when scientists using Hawaii's Pan-STARRS 1 telescope made a significant discovery. This telescope is a component of a large-scale initiative to study the night sky for celestial occurrences. It is intended for wide-field astronomical imaging. The crew had no idea that this night would be a watershed in our knowledge of the cosmos. An object that has never been seen before was discovered by the Pan-STARRS 1 telescope as it searched the sky. At first, astronomers thought they had found a normal asteroid, but when they examined its features and speed, they realized it was not a regular space rock. Oumuamua was on a trajectory that suggested it had originated from outside our solar system and was moving at an incredible pace. Humanity has never before spotted an intergalactic traveler, a visitor from a far-off star system that was traversing our cosmic neighborhood. The way that Oumuamua looked and behaved instantly distinguished it from other known space objects. Unlike any comet or asteroid ever seen, it has a long, cigar-shaped body. According to estimates, Oumuamua is more elongated than any object we have seen in our solar system, measuring about 800 meters in length but just 80 meters in width. Because of its unusual shape, some have compared it to a celestial cigar or cosmic needle, which has made scientists wonder how such objects may develop. Additionally, as Oumuamua traveled through our solar system, it showed peculiar movements. It suddenly accelerated as though something was pulling it faster than the sun's or other celestial bodies' gravitational pull could explain. The mystery surrounding Oumuamua was further heightened by this unpredictable behavior, which sparked a flurry of theories about what it could be. Some speculated that it might be a piece of a larger body, while others believed it might be an asteroid that was ejected from its home system following a collision. But the most radical notion was put up by a group of scientists who proposed that Oumuamua might be a man-made object, a probe launched by a highly developed alien civilization. The object's extraordinary acceleration, which some hypothesized might be the result of solar radiation pressure acting on a thin, flat material similar to a light sail, fueled this notion. The public's interest in the quest for intelligent life beyond Earth was rekindled by the possibility that Oumuamua was an alien probe. Following the discovery of Oumuamua, scientists worldwide rushed to collect as much information as they could before the object left our solar system and vanished into the emptiness of space. But even with their best efforts, a lot of questions were still unanswered. The James Webb Space Telescope can help with that. The most sophisticated space telescope ever constructed, JWST was launched in December 2021 and has significantly more capabilities than the Hubble Space Telescope, which it replaced. It is intended to view the cosmos in infrared light, which enables it to see through dust clouds and identify things that are too far away, too dim, or hidden for other telescopes to see. Oumuamua and other interstellar objects have been seen from a different angle thanks to the James Webb Telescope. JWST can take precise pictures of these objects and determine their chemical makeup because to its cutting-edge equipment and unmatched sensitivity. Understanding the true nature of Oumuamua and other enigmatic extraterrestrial visitors requires this capacity. Researchers now have a better understanding of Oumuamua's surface and new hints regarding its origin thanks to the James Webb Telescope's first actual photograph of the island. The James Webb Telescope can examine the faintest and most distant objects in the universe using its high-resolution cameras and spectrometers. Because of this, it is a very useful tool for researching interstellar travelers such as Oumuamua. These objects' temperature, composition, and even the presence of volatile components like water, ice, or organic molecules can all be ascertained by JWST by analyzing the infrared light they emit. By making these observations, scientists can learn more about Oumuamua and ascertain if it is a natural phenomenon or something more unusual. The very elongated shape of Oumuamua, which distinguishes it from the majority of known asteroids and comets, is one of its most puzzling features. The extraordinary proportions of Oumuamua are unlike anything that has been seen before. Comets and asteroids in our solar system are typically more spherical or irregular in shape. The formation of such an item has been disputed by scientists. One theory is that Oumuamua was formerly a long, thin fragment of a bigger body that was broken apart by a collision. According to a different scenario, the object might have been stretched by tidal forces when it approached a large planet or star in its home system. The behavior of the thing also sparked curiosity. Gravitational forces alone were unable to account for Oumuamua's tiny but surprising acceleration as it traveled through our solar system. This oddity raised the possibility that outgassing or another force was at play. When a comet-like object heats up as it gets closer to the sun, volatile materials vaporize and exert a little but powerful force on the object's speed. This process is known as outgassing. However, scientists were baffled when they found no indication of similar outgassing in Oumuamua. The mystery was increased by the absence of a coma or tail, which are characteristics usually associated with comets. As comets get closer to the sun, the sublimation of ice from their surface typically results in a brilliant halo of gas and dust. However, Oumuamua did not exhibit any of these indicators, indicating that it might resemble an asteroid more. Its inexplicable acceleration, however, seemed more in line with a comet. Oumuamua is one of the most fascinating things in recent astronomical history because of this paradox. Both scientists and the general public have been captivated by the idea that Oumuamua might be a man-made object. Harvard astronomer Avi Loeb is renowned for suggesting that Oumuamua could be a spaceship or probe launched by an extraterrestrial civilization. According to Loeb's theory, the object's remarkable acceleration may have been caused by a light sail, which is a tiny, reflecting structure that propels itself using solar radiation. In this scenario, Oumuamua might be a piece of alien technology that has been deployed on a reconnaissance mission and is now drifting across space. Although the public is fascinated by this concept, the majority of scientists are still dubious. Most people agree that Oumuamua is probably a natural thing, even if it is quite uncommon. Although intriguing, there is no hard evidence to support the extraterrestrial probe theory. Nonetheless, the fact that Oumuamua's actions are difficult to explain has allowed for the possibility of more unusual theories. Although study on the hunt for extraterrestrial intelligence, SETI, has long been on the periphery, findings such as Oumuamua demonstrate that it is worthwhile to be open-minded when venturing into the unknown. Without the Pan-STARRS-1 telescope, which is situated atop Haleakala, a dormant volcano on the Hawaiian island of Maui, Oumuamua would not have been discovered. The goal of the Pan-STARRS-1 project is to identify near-Earth objects, NEOs, that could endanger our planet and other fleeting celestial events using its panoramic survey telescope and fast reaction system. The telescope is perfect for finding new objects because of its wide-field imaging capabilities, which enable it to scan vast areas of the sky in a single night. With its powerful 1.8-meter diameter mirror and state-of-the-art imaging equipment, Pan-STARRS-1 can take comprehensive pictures of the night sky. The purpose of the telescope is to continuously examine the sky and take pictures of asteroids, comets, nebulae, and galaxies in the distance. Additionally, it participates in the hunt for near-Earth objects that might strike our planet. Actually, the telescope has already found a number of significant objects, such as comets, asteroids, and even other interstellar objects. Since Oumuamua was only visible for a brief moment before moving out of range, its discovery was a fortunate break. Astronomers soon concluded they were seeing something remarkable when Pan-STARRS once spotted Oumuamua during one of its routine sky surveys. Our knowledge of Oumuamua's size, shape, and trajectory was improved by follow-up observations taken with other telescopes, including as the Very Large Telescope, VLT, of the European Southern Observatory in Chile. It is quite difficult to study a thing like Oumuamua because it was traveling through our solar system. Before it vanished into space, astronomers had a brief window of opportunity to see it. 11 days after its discovery, scientists rushed to collect as much information as they could before Oumuamua became too dim to see. Observatories from all over the world had to work together in this race against time, each providing important information that helped solve the enigma of this intergalactic visitor. The peculiar course of Oumuamua was one of the main obstacles to its investigation, in contrast to the majority of objects in our solar system, which orbit the Sun in predictable ways. Oumuamua traveled through our solar system in a single direction, or hyperbolic. This complicated efforts to track it because it was hard to forecast exactly where it would be at any one time. The object's faintness presented another difficulty. Due to its small size, Oumuamua was already drifting away from the Sun and getting harder to spot by the time it was found. Even with the use of some of the most potent telescopes on the planet, astronomers were only able to acquire a small amount of data. Even though Oumuamua has long since departed from our solar system, it still fascinates both the general public and scientists. In an effort to learn more about its nature and origin, researchers are currently examining the data gathered during its brief visit. Our understanding of interstellar visitors is being improved by additional sightings of objects similar to it, and theoretical models are being constructed to explain its peculiar shape, velocity, and acceleration. Actually, there are other interstellar objects that have traveled through our solar system than Oumuamua. Astronomers found 2I/Borisov, a second interstellar visitor, in 2019. With a discernible coma and tail, 2I/Borisov acted more like a typical comet than Oumuamua, which defied many of the comet's features. A useful point of comparison for comprehending Oumuamua and other possible interstellar objects has been made possible by the finding of 2I/Borisov. Future research on interstellar objects will heavily rely on the James Webb Space Telescope. JWST is perfectly equipped for discovering and analyzing objects like Oumuamua because of its unmatched sensitivity and capacity to observe far-off, dim objects in infrared light. There may be additional chances to learn about the enigmatic visitors who traverse our solar system when the telescope continues its mission and finds new interstellar visitors. A new chapter in our knowledge of the universe has been opened by the finding of Oumuamua. This mysterious object has encouraged scientists to think creatively and challenged our assumptions about space. Regardless of whether Oumuamua is a natural phenomenon or something more remarkable, it has sparked awe and interest that will propel further space exploration. We are in a position to make even more revolutionary discoveries now that the James Webb Space Telescope is operational. The telescope will enable us to investigate interstellar travelers like Oumuamua with a level of precision that was previously unattainable because to its unparalleled ability to see faint and distant objects. One thing is clear as we continue to unravel the universe's mysteries. Oumuamua is only the beginning. We have only just started to explore the enormous and surprising universe that exists outside of our solar system.